Hello everyone, I'm Chris Bellamy. I'm going to do a talk on scaling UI tests with AWS and Docker. It's basically going to be sort of a recap of like our journey from taking a bunch of different testing approaches and sort of pulling them into one main effort, and where we went from and where we are today. I'm a software engineer. I've been a software engineer for 4 years. I've been at Sky Betting and Gaming for the last 2 years. Yeah, so we'll get started. If anybody needs to ask any questions or anything like that, that's fine. If there's anything that is not clear or you want me to sort of clarify something, don't hesitate to ask. So basically what happened was I came to Sky and there was a bunch of different testing efforts that were in various states. Some were more mature than others, some were basically somebody's pet project. They weren't sort of run that much, they weren't maintained. They just basically there was something there that sort of every now and then somebody run it, not getting much value out of it. So some of these projects sort of matured and became part of like the main sort of run. I'm going to focus on what happened where we took the sort of gaming portal. So I don't know if you've ever used Sky Bet, the sort of gaming side of things. We've got 3 main products, well 4 including poker. So we got like casino, bingo, and Vegas. And basically we needed a solution that sort of worked for all 3. So each of these products had frequent releases. There was constant change to the code base several times a day. I'm sure you've probably experienced that. It becomes tough for manual testers to sort of keep up with this constant change. They're always having to test regression, and it's just tedious. So we need automation to fix this sort of thing. So how can we make testers from blowing the brains out into very happy testers? We need automation, obviously. You've probably all had experience with automation. This is sort of our journey with it, and hopefully you might learn something from what we did, or you might do something completely opposite. So how hard could testing be for automation at scale? Quite hard, really, in practice. So the initial sort of impetus behind it was to have what we called the test automation accelerator, which was we basically got a crack team of engineers together to go, right, well, how do we actually solve this problem for the future, rather than just plastering over it and hoping for the best. So we decided on a bunch of criteria that this solution had to meet. Product teams have got to own it. You can't really, or in our experience, it was very difficult to sort of get testing off the ground, because as soon as you've done one sort of bit, the product team's already moved on, and you're forever chasing your tail. You need the buy-in from the teams. You need to make them want to use it. It needs to be automatic, so people don't have to have a conscious effort to actually run this stuff. And it needs to be visible. People need to be able to see it, and not just the development teams, but other people in the business. Ideally, you want a big red flashing light when something goes wrong, that somebody walking past the desk goes, why is that red? And that lets people basically fix it. So what we wanted to do was essentially meet those requirements, bring the sort of disparate testing efforts into one sort of banner, but with the idea of going, right, well, now we've built this thing, that's yours now to sort of build upon. And then obviously we would keep increasing the sort of feature set, and it would essentially become a service that teams could consume for automated UI testing. So what we thought was the best thing to do was to take, rather than reinventing the wheel, take an existing framework that works, but extend it, so put in functions that are business specific, but also can help the sort of wider business sort of understand what the UI testing is, so better reporting, nicer sort of graphs and stuff like that. The things that people like to look at and go, oh yeah, there's a graph there, that means that's good. It also had to be generic because of the specific problem that we had, where we've got 3 products that share a central core, which is our sort of core account framework. So everything logs in through a central account system. But each of the portals are different. They've got different code bases. They might look the same, but under the hood they're totally different. And we needed to be able to, if new products came online or new devices or new automation support, things like Selenium, Appium, etc., it needed to be you'd be able to just plug in that stuff and it'd just work. So we came up with gaming codeception. So it's built up on top of codeception, which is a PHP BDD-ish automation framework. It's not BDD like Cucumber. It sort of works on the test script's kind of human readable, but it's still code. Basically, the test scripts aren't just text files that are then interpreted. The actual code is what is used for executing the test. It can be referenced across each portal code base. So it's important that we have a central, sort of project that had a bunch of code in it that shared across all the portals. Whenever we needed to fix something, we only have to fix it in the central code base, and then they just need to pull in their dependency and update their portal to get the new stuff. So some functions that we did was essentially the focus was to sort of smooth the process of UI testing. A lot of UI testing tools are kind of generic in that they have to be because they have to plug into a lot of different portals. Now that doesn't necessarily mean that we've reinvented the wheel. We have sort of smoothed certain interactions with the underlying framework that better fits our process. So things like handling cross-origin. So because of the implementation of our backend, we have some certain quirks. I don't know how to sort of say it. So basically we had to hack around that. Essentially, Selenium likes to talk to domains, and if you talk to another domain from a different domain, Selenium goes, well, hang on a minute, that looks like cross-site request forgery, and it'll block it. So we had to sort of massage around that, because that was just one of our sort of implementation quirks. We talk to different domains a lot. It needs to handle window navigation, so we are opening windows for like games, closing windows, opening extra ancillary sort of support pages, and we needed to be able to sort of get in and out of them and know kind of where we are. So if we open a bunch of different gaming sessions, we know where we are. Setting up testing sessions, mobile device specific functions, so like rotating devices and things like that, stuff that the underlying system didn't have. We needed to be able to sort of create accounts for testing and staging environments, and basically configuration switch for different environments. All of this is sort of to essentially go to a development team and go, look, we've got all these nice functions. Please write UI tests. If there's something that you need, we can write it and put that into the framework. If there's some use case that you're not sure on, or you're not sure how to test it, then we're there to sort of solve that, or at least sort of collab and sort of work out a solution that best fits everybody. So the way that we do that is that we use dependency inversion. So any software engineers, any sort of developers will probably know what dependency inversion is, but for people that don't know, it's where you sort of move the dependency from your code away and you abstract the implementation away from your actual concrete implementation of the code. So you're dependent on abstractions, not the other way around. So essentially you can code things that are generic in shape and plug anything that will meet that criteria into your code. So the main sort of patterns that we also use are screenplay actor pattern. I've got there's some resources at the end of this presentation if you want to sort of find out more information about that. I'll go into a bit more about that in a bit. Page object patterns. Page object patterns is a really, really common pattern that most sort of Selenium frameworks will use. So we, the way that, the reasoning behind this is so that because we have to support a bunch of different portals, we needed to make sure that when changes are made to the portals, that the sort of underlying structure of that code still plugs into our sort of central framework. So the central framework doesn't actually know about the concrete implementation of how the portal logs in or how the portal does certain actions. We sort of provide support for those actions. So if a test requires somebody to log in, we can provide that login dependency, but we don't actually know how to actually log in. The portals tell us how to log in, and we handle it from there. So this is sort of an example of the sort of login on desktop. So we are sort of platform agnostic. We don't really know what the actual requesting device is. We will request that when the tests start. We find out what environments we're in, and then we have it's essentially a flow of how login works. So none of this actually knows the actual underlying implementation. We can plug that into any of our products, and as long as you have a top bar and a sidebar defined with the right functions on it, it can log in. So we have obviously we've got two interfaces in order to enable login. So we've got a sidebar interface, a top bar interface. As long as your top bar and sidebar meet those interfaces, you can have access to basically every single function that we provide in Game and Conception. So if the login flow changes across all the products, we can just update that, or if one product changes how their login flow works, then we'd need to obviously move that into a different method and sort of segregate that out. But essentially, the Game Conception doesn't actually know how to do any of this stuff. It just sort of maintains the flow, and the actual portals are responsible for pulling that in. It's important for the portals to sort of own that, because they're the people who know the most about how their code works. We can't be too restrictive on how login works. It has to be generic, because otherwise we'd have 3 different login flows for every single product, and it just becomes unmaintainable. So that's this interface. So as long as you've implemented those methods, and same for the top bar, login will work. And for example, this is the concrete implementation of a fill-in login form in the portal. So this knows what bits and pieces that it needs in order to actually do the work. You can see this get tester at the top is basically our sort of actor pattern. So we pull in an actor that has a bunch of other functions that it knows how to do its job, So things like wait for element, fill fields, click, things like that. So a bunch of those functions are part of Codeception, but we've added our own stuff in there that sort of fills the actor out with more things that it can do. So essentially what that means is that now you've got a way of writing tests that essentially looks like, although it is quite codified, it looks like a test script. You can see in plain English what the test's actually trying to do. So we want to log into site successfully using a verified user. So we go to the home page, we make sure we've got an account of type, we log in, and then we check that you can see in my account and you can't see a login button, and that's a test that knows how to log in. So if any of those underlying structs change, then the test never has to change. The test always does exactly what it's supposed to do. If we need to change that login struct, then if that's what we need to do, then that's what we need to do. But generally, you go to the home page, you get an account, and you log in is pretty much everything that you need to do to log in. The sort of login method here comes from gaming Codeception, and that is then provided data from the actual portal on how that actually works. Because we're doing that, it means that your tests become a lot more maintainable. Generally, you can pretty much take that test and put it on any portal and it'll work as long as you pass in what portal it's running on. The Vegas portal stuff is basically a factory pattern that just essentially gets every object that it needs in order to do its job to sort of describe what a portal is, and then the tests utilise that. But yeah, you could swap Vegas portal for Casino portal or any other sort of portal object. As long as it meets those interfaces, that test will work on anything. So we've got several portals, good number of tests implemented, but how do you get people to keep running them? Well, the answer is you don't make people do it. You make computers do it, because that's what we're doing, automation. So we're automating the running of the tests, we're automating the actual tests themselves. And so we use Jenkins and Docker. So essentially Jenkins is, for those that don't know, is a CI build pipeline. It can do all sorts of stuff. It can also take scripts and pipeline jobs that basically are just written in Groovy. It can pretty much do anything you want it to do, really. So we utilised that. Obviously, there's other solutions to that. You might use Circle or any other numerous CI tools, but I think the most important thing is to get the portal code triggering the runs themselves. If it's up to somebody's job to run the test, chances are they're not going to get run. Sometimes, you know, oh, why don't you run the automated tests? Oh, well, Joe blogs the test weren't in, so we didn't do them. You'd be surprised at how many times you hear that. And so every time a release is pushed, we trigger our sort of Docker build job. So Docker is a containerization platform. You can put pretty much anything in a Docker container as long as it will run it might be a bit of software, it might be a bit of code, or it might be a hosting an entire application. What we do is we use Docker to sort of build a snapshot of that particular code release, and then that is part of that Docker container and tagged, and then it's pushed up to our Docker image repo. Each release has its own Docker tagged build that knows specifically what tests it has for that particular code base. So when we deploy it, you know that tag 2246 or whatever has the right tests that were in the portal code base at that time. Otherwise, there, yeah, right, okay, back, sorry. So yeah, we take a snapshot of that build, and as that's deploying, that's sort of collating all that information and putting it inside a Docker build with the sort of test runner, any sort of bootstrapping or anything that we need for like reporting, such as report merges or yeah. So the way it works for us is we get a push from a repo that kicks in our sort of framework stuff. So we build the containers, get all the test artifacts for the current tag build, all while it's setting up an environment for that test to run. So the setup of the environment is in the background. So as a deployment goes to a test environment, for example. Once that's done, we run the UI tests against that particular environment. Then we get some nice reports, I'll show them in a bit, and some visibility on what the actual test run looked like. If that's all passed, or it might have passed with a failure, but we might notify that that's because of something's changed, so we need to actually generate a ticket to actually fix that. Then it'll go to deploy phase, and then we repeat. So then it goes through staging, then through to production, and then the cycle begins again. So we originally started running tests on a little crappy Apple Mac Mini, and it was rubbish. Basically, we built out essentially a little Selenium Grid that ran in the box. Turns out that if you put Selenium Grid on a little Mac Mini, then you can pretty much cook eggs on it. It gets really, really hot because it doesn't like running Docker. It doesn't like running things like that are quite CPU intensive. And yeah, so we went from a sort of Mac Mini to, well, this isn't really fit for purpose. We need to figure out a proper way of doing this. So we decided to build a Selenium Grid in AWS. So that's Amazon Warehouse Services, for those that don't know what AWS is. And basically it's a cloud-based solution that Amazon make. You can build infrastructure in there, you could put services in, or you could just use it as a storage for, like, if you like use like S3 buckets to put data in. But yeah, we used where are we? Yeah, I'll get on to the sort of AWS setup for those that want to know about how we actually built that out. But yeah, we got a config service in gaming conception that makes changing environments. So essentially, each test is written as generic as possible. We don't want to bake in specific environment stuff into tests, because then you write a bunch of tests that, you know, a fifth or sixth of the time don't actually do anything. So it's kind of pointless. So we made sure that tests are written in as generic a way as possible, and then we worry about the sort of environment after the fact. So we have a config service in gaming conception that basically we ask for a JSON file and a YAML file. And JSON just provides things like URLs that the portal knows about, things that it needs to know, like admin services and stuff like that. So each portal has a different set of concerns. We don't really want to be responsible for those URLs. That's their problem. And setting up environments like setting up Chrome browsers, Firefox browsers. If we want to go to something like a headless Chrome browser, then all we do is just provide a new YAML file and it'll work. So got some examples here. So essentially we throw in Chrome, we set a bunch of settings for that Chrome browser. We dictate that in the actual gaming conception stuff. So we add the sort of browser configurations centrally, mainly because it gets complicated having portals know about configurations of devices. It's easier if we maintain them centrally than if we want to add a new device to the system. We just add it once and then everybody gets it. So like an iPhone, which talks to an Appium system, or if you want to just plug it into Source Labs, you just bang in your details and that's it, done. So the Selenium Grid architecture, unfortunately you can't really see it, but there's a user here and there's a padlock there, if you can't make that out. But essentially what happens is we needed a scaling solution because we didn't know how many test runs were going to be running concurrently. It could be quite a few, or it could be not many, depending on the time of day. So we wanted to utilize AWS to sort of get us into, rather than having a server that just runs Selenium Grid forever and a day and is rigid, and as soon as we hit capacity on that, it's a whole bunch of work to get another server running. We decided to go down the AWS route, so we've got a bunch of auto-scaling groups which run on EC2 instances. So we've got EC2 instances that run the nodes for the actual Selenium Grid. So for those that don't know about Selenium Grid, it's a solution that Selenium provide where it can parallelize the testing effort. So a bunch of people can consume the Selenium Grid and it will assign that test instance to a node, and that will run the tests rather than running one test after another. So Selenium Grid, there's a bunch of Docker images on Docker Hub that you can pull down Selenium Grid, and it will basically give you a setup like out of the box. We essentially took that principle but containerized it in AWS, so we've got a bunch of AMIs. So that's some Amazon machine images that have the nodes and the hubs. Unfortunately, because we want to cover Internet Explorer testing, we're kind of hamstrung by using Windows. Oh, this thing.
It should reconnect if you leave it. I'm so sorry.
It's all right. So yeah, we've got a bunch of AMIs. So we've got one for the actual hub itself and one for the nodes. So the hub runs on Linux. The actual nodes need to run Windows because it needs to do Internet Explorer. Right, that thing. There we go. And as demand on the service increases, we monitor it through CloudWatch. It's important to have metrics on this. The nice thing about CloudWatch is that it can plug into things like Grafana, so you can get nice graphs that you can show to people. And everybody knows that managers love graphs. So this is, you can't really see it on here, unfortunately. It's a bit dark thanks to Grafana's ultra dark scheme. But you can sort of see up here, we've got hub CPU. So what it's designed to do is, as soon as that hub CPU hits 60%, that triggers off an event in the Elastic Load Balancer to go, right, we need to start firing up some more nodes because we're about to hit capacity, and that will then trigger an event. So you can sort of, this is at 20 to 1, and up there sort of 13:30-ish as the graph starts going up, that sort of hits the load balancer, and that starts scaling the instances of those nodes. Once demand creeps back down, we pull them back because the more stuff you have on AWS, the more money it costs. So it's important not only to make sure that you're only putting the actual power that you need for just, there's no point in putting a ton of node, it also costs you a load of money. So that's one thing to sort of be careful with AWS, is that it's great for putting out these sorts of services, but there is a cost to doing that, and that flexibility means that the more nodes that you run, the more money you end up consuming. So it's just a conscious effort to sort of be mindful of that. But they do make it quite easy, being able to put in CloudWatch metrics on any sort of thing. So you can put it on memory, the amount of disk space that's left, the amount of memory, the amount of CPU usage. There's a ton of metrics that you can sort of watch, and then automatically we can pull that out and put that in our sort of Grafana dashboards, and people can see it. So we have this running during business hours, It's set to descale after 6 o'clock, and we run basically just one node, just for because service desk and other outside of gaming might want to run the automated tests just to make sure that if we have an outage that they can run these tests and make sure that we are okay, and we're not wasting time sort of smoke testing this stuff manually. We could just fire the automation off and we go, right, okay, it seems okay now. We can end the incident. So once you start doing Selenium Grid, you start noticing, well, we've got these nodes. What happens if we throw all as tests at one Selenium Grid or a bunch of Selenium Grids that are running nodes? You can massively reduce the amount of time it takes to run tests. Well, you can't speed the test itself up. Your runs are always going to be as slow as your slowest test. But if you've got 30 tests running on 30 nodes and your longest test is 2 minutes, then that's how long your test runs. The problem with that, though, is that you run into resource issues. So things like, in our case, for our sort of test environments, we can just generate accounts on the fly and discard them. That's no problem. But on live, we need to have vetted accounts that fraud and risk know about, and we need to be able to just kill them accounts if we need to, for whatever reason, security reasons. And you run into a problem where if you're checking balance transactions and things like that, so deposits, withdrawals, you don't want to have one account that's being used by another test, and you might deposit on one and withdraw on the other, and the test fails because the account doesn't add up to what you expected it to do. So you need to consider that if that's how your testing works, because we can't just fire up accounts in live, because we need to have ways of withdrawing and depositing. It's not possible for us to just do that. We have to go through a process that's slow, to email and get accounts and stuff like that. So we built the automation user service, which again is in AWS. It's a serverless architecture, so it doesn't have it's not running on like an EC2 instance or anything. What it actually uses is it uses a combination of DynamoDB and API gateway in AWS, and so there's no server. We can just deploy that as and when we need it, and what that does is it essentially provides a global lock of account resource. So you can use that to lock any type of resource if you need to sync runs across multiple threads, or you need to sync a resource across a bunch of different stuff. You can just plug into this automation user service and it will do exactly what it needs to do. You lock a resource, you can unlock a resource, and that's pretty much it. It works kind of like what you can use Redis caching for, to provide distributed locks across the system to maintain state, although most people don't tend to do that these days. But it's useful for us because we need to guarantee that that one test run has that one account that nobody else is touching. It also drives this test account health check service, which I'll go into a bit more detail. So essentially what happens is a test run will start, it will lock a resource, that hits the user service, so it's the API gateway and saying, I've got this account, and it tries to lock it. And that lock is basically a SHA-256 hash. If it hits a collision, then it rejects the account, basically to say that's in use, don't use it. And then it just gets another one, and it'll just go through a list of known accounts that we know until it gets one that works. But that is fast. It'll take a second to run through all the accounts to do it. It takes milliseconds. Once you've got that transport in, it's milliseconds to sort of go through the locks. Once it has locked, that provides another SHA-256 hash, which is essentially the key for the lock, and that is then known by the running test process. So if the test fails, we can unlock it using that key. If for some reason that fails to unlock, or if the test instance crashes for whatever reason, the locks are set to live for 2 minutes anyway, so that it'll disengage the lock automatically. Now, obviously, that might mean that we'll have some collisions, but rather than locking every single account in case something catastrophic happens, it seemed to be a trade-off that we're willing to take, and so far that's not really caused any issues. So, another design that I wish I'd have put in white instead of black. So there's what's supposed to be is a bunch of users here in the middle. So the UI test framework will call a service that sort of provides it test users, and it will go through each one in turn trying to lock the account. Once it gets a lock, it knows that account isn't used anywhere else, and that's not just that particular run. That can be any run anywhere. So because it's a global lock and every single thing goes through our gaming codeception, we can control the flow of how test accounts get divvied out. So we can basically control how and what accounts are being used at what time automatically, and when if a user fires up their testing on their own machine, then it knows about that because it has to go through this in order to get an account. So everything hits this user service and gets a lock. So it hits the user surface, which contains the ability to talk to the API gateway. And then the API gateway is essentially a REST interface that locks data into a DynamoDB database, and that's it. It's really simple. It's literally just two things and a bunch of code that sort of interacts with that. But anything can plug into that API gateway, not just automation. We call it automation user service because in context that is providing automation users, or rather test users for automation. But anything can plug into this distributed locking mechanism, so you can use it for a bunch of different stuff. So we also use it to do the account health check service. So obviously we have a bunch of accounts that are a dependency for us, and it's a problem when you have accounts get into certain states that can't be used. So there's no point in having a bunch of test accounts if they're all locked or in invalid states, so we can't use them. You end up getting failing tests, and we don't want that because we want people to buy into a system, and we need to provide them things that work. If they don't work, then they lose faith in it and they go, well, we're not going to use it anymore, we'll just use our own because it doesn't work. So what it does is it locks accounts every night that we know of. So we have a pool of test accounts that we have access to. It runs through all those accounts, making sure that it can log in and that the account's in the right state. And then anything that fails, we log why it's failed, and then we lock the account in the AWS. That way, when subsequent test runs are run, they don't run into these broken test accounts that don't do anything. And then somebody can come along, look at that report and go, all right, well, this one it's got a new terms and conditions, so it just needs to accept that, and a manual intervention brings that account back online. Some might be more problematic. They might have been caught in one of his sweepers that sort of invalidates accounts that look dodgy. And then you just need to talk to whoever is responsible for unlocking that manually. So yeah, as you probably know, UI testing is slow. There's a reason why in the sort of testing pyramid, you stick UI tests at the top because they're slow and expensive. Now, obviously, there are UI tests can be quite valuable in that they touch a lot of stuff just by nature of the way that they work. So things like logging in will touch on quite a few services, or simply just loading the home page will hit a bunch of services. So you get that nice sort of integration test at the same time as, well, have we had a regression during this software release? So as you can see there, our casino tests take 10 minutes to run, which is quite slow. It's not mega slow, but it could be better. So that's due to it just running tests one by one. So on a single node, it will literally hit every single test, and the next test will only start until the last one finished. So there's ways you can sort of fix that. You can do parallelisation, but sometimes that's not necessarily the right choice. What you can do is you can sort of segregate certain tests that aren't super important. So things that test things like opening sort of links and our sort of regulatory stuff, we can test that in a separate job that runs periodically throughout the day. Same thing for like moving from, because we have a single sign-on that we have to basically make sure that it works. So we hive that off into a separate system that tests just that cross-portal interaction. And that way you can sort of make your test runs a lot faster, because you're not, you're testing sort of what we would call like silver journeys rather than gold journeys. So your gold journeys are things like login, deposit, withdrawal, stuff that we need to make sure works, and it needs to work every time. The stuff that we don't particularly care about, but we do, we just want to know whether it's failed when it fails, can just go into another job. So sometimes a lot of UI testing frameworks will get bogged down in the, we must parallelize it because that's how we get faster tests. But not necessarily. You can move non-important tests out of your main CI pipeline, because at the end of the day, if a manual tester is going to check this sort of release, the main things that they're going to test are things like log in, log out, deposit, withdrawal, etc. That doesn't mean that we haven't done that. So we have parallel runs. So we've taken an 11-minute run, and that's now 3 minutes. So we essentially we basically carve the test suite into as many chunks as possible, and then throw them in as many Selenium nodes as we can. That feeds us back whether or not the test passed, and then we merge those results. So I've got some XML and some HTML report mergers that run after that run has completed, that sort of takes all those little reports from all the separate runs and puts them into one based on a tagged run, and then publishes that report to Jenkins. So they're just, they run as soon as the test's finished, and it just shoves everything into one file, and then that is nicely uploaded to Jenkins. Now I've just realised I have lost connection to the VPN, so I can't actually show you these reports. But well, I'll come back to that when I get there. So part of our, if you remember back to the beginning, part of our sort of requirements for this was to make it visible. So like the Selenium dashboard that is on a big flat screen that people can come along and see, we have this next to the service level managers. So basically exactly where it needs to be if you want people to shout a lot about it. And this basically sits on a big monitor, and as releases go across the portals, they trigger each individual build and will then run the tests, and it will either stay green, which is great, or it goes red, and then somebody comes and shouts about it. Also, in each individual squad, we've got smaller subsets of this. Obviously, not every squad cares about other people's test results. So we just put the single portal stuff on one screen so that somebody could come along and go, why is that red? And somebody can go, the test failed because we changed something in the flow and we didn't update the test. So they can go and fix that. So yeah, to summarise, what we did was we needed product teams have got to own it. It's impossible for one team to control the flow of development on a bunch of different products. Our specific scenario might be different to other people. You might only have one product that you care about, which is fine. But I think it's important to get developer buy-in for this stuff, because ultimately they're the ones that are making the changes. They know when the tests are going to break if they've implemented them, and they can make those changes as and when they do it. There seems to be that sort of attitude of UI test is a tester's job. It seems to be, well, from my perspective, seems to be eroding a bit more. People seem to be a bit more receptive to the idea of having these suites of tests. But it can't hurt to get developer buy-in. Plus, having that experience as well can feed back into your UI testing project, because they probably have been or will have been doing this job for years. And you know, if you're new to sort of development, then it's always nice to have that sort of wealth of experience to sort of lean on. So yeah, needs buy-in from the teams. In order to get that buy-in from the teams, you need to make sure that the actual framework is easy to use. It needs to do a lot of work to sort of massage those UI tests into being a like the one that I'd sort of displayed earlier, where you have literally a test script that looks easy to read. Anybody could look at that actual UI test and go, oh right, I see what that test is actually doing, and they would be able to do that manually. It has to be automatic. Relying on a person to run UI tests means you're setting yourself up for failure, really. People forget. It's as simple as that. Or they don't get run because there's somebody not going, we need to run out UI tests constantly. So you just make it automatic. Make it automatic and then display that result. Whether it's passed or failed, as long as you're running it automatically, that's how you get the sort of buy-in for this stuff. Oh, good, it fit on. And they have to be visible. So even though it might look ugly, it might look like every single test is failing, sometimes it's important for that stuff to go red, because people who aren't technical or aren't developers or who aren't part of the sort of business ownership process of that particular team comes along and goes, why is that thing red? Should that thing be red? And it makes people have take responsibility for it. If you didn't have that, people would just ignore it. And yeah, I can't stress the importance of put a dashboard somewhere, even if it's the ugliest thing ever, like the Jenkins stuff. They're not pretty, but it's a big green light and it's a big red light for people to see what's going on. Yeah, so has anybody got any questions about any of this stuff? Yeah.
In terms of buying from the team, it's obviously important to have confidence in the test. How do you manage that test flaky and sort of deal with those?
Sorry, repeat that last bit again. Sorry.
How do you deal with tests that are flaky, especially when you've got differences between like Chrome driver, Firefox driver, Internet Explorer?
Yeah, that's probably the biggest challenge. Really, is sort of fixing that sort of stuff. But that's kind of one of the reasons why we went down the central sort of shim on a existing framework, was that as things get fixed in the main framework, we also can fix things downstream, so we're not sort of dependent on like WebDriver fixes and stuff like that. So Chrome driver will and can screw you every now and then when they put out a new nightly build and none of your tests run. So we don't really want to be dependent on that. We want to sort of be able to move fast and fix that sort of stuff. Getting around test flakiness is, there's an knack to it. It's trying to, rather than altering the flow of a test, sometimes it might be that that fails for a good reason, and then it might be that that test is no longer valid anymore. Alternatively, you can put in a sort of alternative path. So we have an issue where in Selenium, if a React component re-renders itself, you get a reference of the sort of element that you're wanting to click, but then by the time it actually clicks it, that element's re-rendered and you get a stale element reference. So we just override that method, and we have our own sort of, we catch it, so we catch the exception and then go down an alternative path or retry and until we get it. But yeah, does that answer your question? Anybody else?
As it gets down to code, do you send notifications?
Yes, we do. So in our Slack channels, we'll have like a bot channel for each product, or some of them just have it straight into their actual team Slack, and it will say build started, test was passed, test failed, etc., with links through to the actual running builds and stuff. That's sort of, yeah, Slack integration with Jenkins sort of takes care of that. Yes.
Buying from teams,
Yeah.
do you find that it takes somebody with kind of a tester's head on in each team to have buy-ins, this kind of thing, or do you find developers to be quite receptive to it?
I think it's like 80-20. I think, yeah, you do need that sort of somebody who is sort of well into testing to sort of almost sort of be a almost like a spokesperson. Well, yes, it is important to sort of work with those people. Generally, there's a handful of people who we know we can go to about this stuff, and we can then talk to them. But generally, I think the tide is turning. I think more developers are sort of getting seeing the actual virtues of this sort of approach, and it is changing. But yeah, I think the vast majority, you do need somebody in there who is like your sort of advocate for testing. Anybody else? Yeah?
Cool. Thanks very much.
Cheers.